You know, when you see a big piece of machinery, flipping a switch to off feels like you've made it safe, right? Simple. But what if I told you well, it's often not nearly enough. There's this huge, dangerous gap between a machine being off and it being truly isolated and safe. And that's what we're going to dig into today. We're going to solve this energy isolation puzzle using the UK's PUWER regulations as our guide to figure out why these safety failures happen way more often than you'd think. All right, here's the plan. We'll start with the puzzle itself. Then, we'll see what the official PUWER regulations actually demand. After that, we'll get to the heart of it, the 3 critical gaps where things go wrong. We'll even do a quick comparison between the UK and US rules and wrap it all up with a super practical walk-the-floor test you can use to spot these problems yourself.
Okay, let's dive right in. The energy isolation puzzle. It really is a paradox in workplace safety. I mean, think about it. Everyone agrees that isolating energy is absolutely critical. The rules seem pretty clear. So, why do investigators keep finding the exact same mistakes time and time again after an accident?
And that leads us to this massive question, the one at the core of everything. How can a machine be switched off but still be incredibly dangerous? The answer is all about understanding what safe really means. So to figure that out, we've got to look at the rulebook. In the UK, the big one is the Provision and Use of Work Equipment Regulations. Everyone just calls it PUWER. This is basically the Bible for machine safety. And Regulation 19, that's the part that deals specifically with isolating energy. So what does PUWER actually mean by energy isolation? It's way more than just flipping a switch. It's about creating a secure break in the energy supply, a break that makes it impossible for someone to accidentally turn it back on. And that word, secure, that's everything. And this is where it starts to get tricky, because we're not just talking about electricity. PUWER covers all kinds of energy. You've got hydraulic and pneumatic systems with massive amounts of pressure. You've got mechanical energy, like a giant compressed spring just waiting to release. Even things like thermal energy, or just good old gravity holding a heavy component up in the air. That's potential energy right there. The real trick and the real challenge is finding and safely controlling every single one of these before anyone gets near that machine. All right, so if we know the rules and we know what we're supposed to be isolating, why do things still go so horribly wrong? Well, it turns out investigators find the same 3 problems over and over. Let's call them the 3 critical gaps. This is exactly where most safety programs completely fall apart. Yep, there it is. 3 recurring failures that can undermine even the most well-intentioned safety plan. We're going to break them down one by one. Because if you can understand these, you're on your way to closing that gap between just off and actually safe. First up, and honestly, this is the most common one you'll see. Gap number 1, paper procedures versus plant reality. It's that huge, dangerous gap between what the safety manual says and what's actually on the factory floor. And this is a perfect and terrifying example. Look at this. The procedure on the left, maybe it was written 5 years ago. It tells the technician, hey, go lock out these 3 points. Simple enough, but reality on the right tells a different story. The machine got an upgrade last year, and now it has a 4th isolation point, one that's not in the old paperwork. So a technician, doing their job and following the rules, is literally walking into a trap. They think they're safe, but they are absolutely not. Okay, moving on to the second major gap. It's not just about the paperwork. It's also about the hardware, the actual locks and tags. This quote here really nails it. A lock is not just a lock. It's part of a system. The problem is, way too often, it's just not treated that way. So, what do investigators find? A mess, usually. A totally informal system. Maybe a random box of padlocks just rattling around in a toolbox. There's no standardized system, no unique locks for each person, so you have no idea who locked out what. There aren't any hasps, those devices you need when multiple people have to work on one machine. The whole safety process just crumbles right there, at the physical point of control. Which brings us to our third and final gap, and this one is all about people. It's the critical and really dangerous mistake of assuming that just because someone is experienced, they're automatically competent for every single job. Think about it. Just because your best maintenance tech has 15 years on the job doesn't automatically mean they know the ins and outs of a brand new machine that was installed 6 months ago. The solution here is pretty straightforward. Competency can't just be assumed, it has to be proven. You've got to link training directly to specific pieces of equipment. You have to document in writing that a person is competent on that specific machine, and then you have to review it regularly. It's a huge shift from, I assume they know what they're doing, to,
I can prove they know what they're doing. So now that we've seen those three big gaps, let's pull back a bit. I want to compare the UK's PUWER with the system in the US, which is run by OSHA. It's really interesting. A tale of two very different philosophies, both trying to get to the same place, keeping people safe.
And this chart lays it out perfectly. In the US, OSHA is super prescriptive. It gives you a detailed checklist. It says you will have machine-specific procedures, you will do annual inspections. It tells you exactly what to do. PUWER, in the UK, on the other hand, is what we call goal-based. It says, here's the safe outcome you must achieve, in this case safe isolation, and you figure out the best way to get there. It's more flexible. But here's the key takeaway. If your program is good enough for OSHA's strict rules, you're almost certainly going to be fine under PUWER, but it doesn't always work the other way around.
Okay, so what do you do with all this? How can you actually find these weak spots where you work? Well, there's a really simple, practical test you can do. I like to call it the walk the floor test.
It's so simple, but it's incredibly powerful. Just walk out onto your plant floor and pick one machine, totally at random, and then you ask these key questions. First, does the written isolation procedure match the machine as it stands today? Second, is the right lockout hardware for that machine readily available and in good condition? And third, can you prove that the person who would do the job has documented competency for this specific equipment? If you hesitate or answer no to any of those, boom, you just found a dangerous gap.
And this really brings it all home, doesn't it? If a simple test like that can uncover a hidden danger, like an outdated procedure or missing equipment, it really makes you wonder, right? What other risks are we just not seeing? And that, right there, is the real puzzle we all need to be focused on solving.